Hey guys, this is Jero Serrano, and thank you for joining me once again on this live stream where I will be doing some more implementations for the game engine. I know it's Sunday and I am a bit tired, but I wanted to do more coding today since basically I have the whole day free. So let's do a quick recap of what I've been working on so you get an idea of where I'm at. All right. So if you joined me last yesterday, you probably saw uh, the code that I was working on. But if you couldn't join me, let me just give you a quick recap of everything. So basically, my whole goal that I want to do right now is be able for allow a 3D characters to go up and down a hill, and to do that, I need to add some code to the engine so that it can actually detect whenever it should go up a hill or down a hill. And I did a quick video of what I did on last Sunday, and basically this is a video of the character going up and down the hill, and I want to show it to you. I want to show it to you so you can get an idea of what I'm talking about, right? So here you see the character go up and down the hill, right? So how I do that is actually quite simple. Let me bring this up. The whole idea is this. I have a character here which is my astronaut, and what I do is that I shoot a ray from the center position of the astronaut going down, and then I test whether that ray intercepts with the terrain, in this case, which it would be this section right here, the floor, if you want to call it. And basically, if I break this down here, I check whenever the ray that is shooting down from the center of the astronaut all the way down, I check if that ray intercepts with one of the faces of the floor or a triangle, right? Whichever it is. And if it does intercept with the particular face, I then get a normal vector. I compute a normal vector of that face and use that normal vector to change the orientation of the character. All right. So whenever the astronaut is actually approaching this slope right here, I shoot a ray downwards, and it detects that the ray intercepted, for example, this particular face of the floor. And what I do then, I basically get the norm of that vector, which is shown here in blue, right? That's the normal. And again, I use that normal vector and the direction of the character to basically tilt the character, change the orientation, so that way it creates the whole idea that it's going up. However, how I have it done right now, how it's shown in the video, actually is quite inefficient, because if I let me bring up the other one, slope test idea. All right, yes, let me bring this up. How I have it in the video and how I did it previously is very, very inefficient, because I make the ray basically how can I say this? The ray that I'm shooting down from the character down, from the center of the position of the character down, I do that test now with only one triangle, but with every single triangle that makes up the whole terrain. All right. You can just tell how inefficient that is. Right now, this particular plane terrain has about, this should have about 3,000 faces. All right. So you can, you know, in a game that is that is not acceptable. You should not be doing a linear search on every single of these triangles. There should be a better way to do it, and that is what I was working on basically the whole week and yesterday, coming up with a better way to do the whole search. And how I do it is I do an octree test, octree example. So basically, let me hide this so you can get a better idea. So this is the basically the terrain that I showed you in the previous file. What I do with this terrain, let me just so you can see it. That's a terrain right there. All right. So what I do is, well, why don't I surround or encapsulate the whole terrain in a cube, and that's my cube right there. And then I keep dividing this cube into 8 smaller cubes, and just so you can get an idea, one of those cubes will be this one. This is one of the smaller cubes, one of the child of the bigger cube here, right? Now this cube, I keep dividing it into 8 more smaller cubes, which is shown here. Okay, and then I keep on going even further, and then I get to this one, to that one right there. So what I do is I basically build an octree around the whole model. And now whenever I do the test between the ray and the triangle, what I do first is I do the test between the ray and the big cube first, right? And obviously it's going to be intercepted. Then I search the ray between the 8 cubes that makes up, you know, that are part of the bigger cube. So whenever the ray intercepts with a particular cube, I say, okay, well, my position should be around here. So then I go in further and do a test between with the cubes that belong to the parent cube, right, which will be the smaller ones here. And then I do that another test, which eventually will lead me to the smaller cube that is shown right here. Right? So if you see it now, instead of me doing a test with thousands of faces or triangles, all what I do is I do the test with the triangles that are encapsulated by this smaller cube. So instead of doing thousands of tests, I probably do about 10 or 15 of those, right? And that is a better way to implement something like this. It's a lot more efficient, faster, and that's the way that you should do it. And you know, when you're developing a game engine, that's your main that should be your main priority: efficiency, because a game will run on top of your game engine, right? So if your game engine is slow, well, whatever game is developed on top of it is going to suffer quite a lot. So a game engine should be as efficient as possible. So that's the main idea of what I'm working on. And basically, yesterday what I did, I built the octree, all of these guys right here, and then what I also did, I assigned the triangles that where you at? I assigned the triangles that belong to this particular cube, right? So the triangles that you see here, all of these triangles, I added all of those triangles in a vector container that is part of this cube right here, of this node. All right, so that's what I did. Actually, I think it would be a good idea if I bring up, if you see it, let me bring this up so you can actually see what I did. This is just a quick recap, so hopefully it helps you. All right, so I have my root here, right? My root cube, which is the big one. Then this cube, I divide this into 8 smaller ones, right? So imagine I have 8 more here. Then I keep dividing it even further into smaller cubes, right? And then whenever I get to a particular subdivision, when I say, okay, I don't want to divide anything else, what I do is I assign the triangles that basically that are within the area of the cube, within the volume of the cube, and I store all of those triangles in a vector container. So imagine this is your vector container, and let me do this. And this is how all the triangles that belong to that. What I did yesterday, I basically did this whole thing, the octree, that's what it's called, because you have 8 children, right? Now what I'm gonna do next is basically we need to do a test, right, between the array and the cube. But my gosh, what is that? And then array between and the triangles. All right. I think I'm gonna put this in a particular class, and I'm gonna call it raycast. And this is what we have right now, which is our mesh manager. Our mesh manager is actually basically build the whole octree and assign the triangles. We're not completely done with this yet. We need to think about something else that I'm going to show you right now. So actually, this is a good point, right? So when you load up a game, right, you're going to have a bunch of characters in your game, right? You're going to have your main character, you're going to have some assets here, like a tree, right? You're going to have a house, whatever, right? Now, I have 2 options. I can tell the engine that for every character that is in the scene to build an octree, right? Like what I showed you. On and on. Or I can tell the engine, you know what, I don't want you to build that for every single character that is in the scene, because it's going to take too much memory. What I want you to do is only to build the octree on particular characters that I'm interested in. For example, one of the characters that I'm going to be interested in is in the terrain, right? I want the engine to build an octree around this particular terrain, right? Because I want my character that I'm going to have later on, my astronaut, for example, to be able to shoot a ray downwards and determine which of the faces the ray hit the terrain. Basically, the terrain will have a pointer to this, and from that I can do my search quite fast, which is what I've been showing you. So last night I was thinking, well, I either have the option of telling the engine to build the octree for every single character, or just enable it for some. And I think what I'm going to do, I'm going to do this instead. I'm going to enable it for some. That way I don't consume too much memory, and it's not the engine is not too bloated. And that's the other thing that you need to consider when you're developing a game engine. Number 1 is efficiency, and number 2, you don't want it to be too bloated. All right, you want it to keep the amount of memory that is consuming or taking at a minimum. All right. So let's go and do some coding right now. By the way, can you hear the music? All right, cool. So let me hide this. me do this. Bring this up. Alright, so the class that basically is in charge of all the building the octree around the character is basically this class right here. Ufruity Mesh Tree Manager. This is the manager that is basically, I'm sorry, the class that is in charge of building the octree, assigning faces to a particular bounding volume, and what I worked on yesterday was basically, like I mentioned just to you, I built the octree. This is also part of the whole building, the whole division and the subdivision. In this method right here, what I do in assign faces, I basically assign the triangles that belong to a particular node, basically to a particular cube, right? A cube, in this example, the cube is in axis aligned boundary box. And once you get to a particular point, it is called a leaf, right? And that leaf will have a pointer to a vector container which contains the faces. All right, so we have that. One more thing that I have to mention here: when I build my octree right now, I have it. So when you build the octree, right, you can have several subdivisions. You can divide the octree only up to this particular point, right, which would be subdivision 1. You can go even deeper and go all the way to subdivision 2, and you can keep on going to 3, 4, 5, whatever. Right now, how I have it in the code is only up to subdivision 1, and with subdivision 1, I create a total of 9 nodes, including the parent. What I'm going to do actually, I'm going to divide this to make a subdivision of 2. And that will create 73 nodes actually. All right, so that's how I have it right now. All right, now like I mentioned, we do not want this to be created for every single character. We wanted to just keep it contained to particular number of characters. So what I'm thinking of doing is going to my model here and basically setting up setting up a new method. Come on. Here. Which we're gonna call void enable mesh manager, and the mesh manager will basically initiate the whole process to build the octree. Brief. All right. I'm gonna actually I'm gonna do this to do comment this. All right. I don't want to do the comment right now. The documentation, I mean. So enable mesh manager. All right. So let me go over here. So void u for the static model. All right, and this will basically, well, we need a pointer to our mesh manager. Let's scroll all the way up. All right, so let's put it here, class u for the mesh octree manager. Oh no, oh, don't need that. Only need that one. All right. And here, let's create a pointer. Actually, I'm sorry. I actually do not need that one either. But I want to leave it there. All right. You for the mesh octree manager, mesh octree manager. All right. And what I'm gonna do here, for the mesh manager.h, and I'm gonna include the other one, you for the mesh octree node, because I'm gonna need that. Basically, my my octree node is what contains my my cube, or in this case my AABB volume, my axis aligned boundary volume, and it also has a vector container which contains the index of the faces that belong to that particular cube or node. All right, so here I set the mesh octree manager to null. All right. Okay, no, and we are going to delete this just in case. All right. All right, so here. First thing first, that we do if my mesh octree manager is equals to null. Right, we don't want to be enabling the mesh manager. So this method enable mesh manager is going to build the octree. Right, initially in the initial state, that pointer, that object is null. Right, it's a null pointer. Whenever we call the enable mesh manager, well, it's going to build the tree only if the initial state of the mesh octree manager pointer is a null pointer. Right, so that in case someone calls this method again, you don't rebuild the whole octree on top of the previous one. So it's going, because it's going to create a whole bunch of, spaghetti or something like that. Okay, I forgot that. All right. So mesh octree manager. So what does this need? My octree manager, when we create one, we need a pointer to our model. Well, that would be the self. All right, mesh octree manager, new for the mesh octree manager, and I'm gonna say this, right? I'll just do itself. Home, and then once I have that, I build my octree, and basically that's all what I need to do in this method. Boom. So mesh octree manager, build octree. So this one is create an instance of the octree mesh manager, and this one basically I build the octree for the model. All right. Huh. Okay, well, I know I'm gonna need something else from here. I'm going to need my root node from here. So I think that I'm gonna need that information somewhere else in another class, so I need to get a pointer to that. Alright, so you for the mesh octree manager, get mesh octree manager. I'm gonna need a pointer to that manager somewhere. I know it. So let me just create a method that will give me that information. So return, okay, if mesh octree manager. Well, no, it's okay. I don't need to do it here. Return mesh octree manager. Okay, because the octree manager has actually access to my root node, and I actually need that root node. I actually have a method here that get the root node of that particular octree, and I know that I'm going to be using that later on whenever I need to whenever I do like array cast. Alright, let's see if that actually works. Okay. So what I have here, ignore this line for a second. I'm gonna show you. I'm gonna use that in a second. All right. So here we have our plane that we are loading. Basically, the plane that we have here is octree plane test. No, that's not the one. That one. So in this example that I have, what I have currently is I load this particular plane. Where's the plane? Uh-oh. Great. The plane left the building. Where's my plane? Okay, well, basically, this is the plane that I basically I'm loading into the engine as a test, and let me put it here. There you go. Right, and then as part of the plane, I built the whole octree around the plane, right? So that's basically what I'm doing here. Also, I'm loading the plane. Ignore this, the name for the astronaut. That's the name I gave it. But basically, I'm loading the plane. I'm loading all of the rendering information. I'm adding the child to the scene graph. But now, what I'm gonna do is, I'm gonna do, I'm going to enable Mesh Manager. So now with the enable Mesh Manager, I should go and basically call this function enable Mesh Manager, create my build my octree, have all of that ready, and then what I'm going to do, I'm going to make sure that everything was properly computer done basically. Okay, so I enable my Mesh Manager, did that, all of that. Alright, so now if everything is okay, what I can do now is I can get a pointer to my Mesh Manager, and I'm gonna do it outside of all of this, so I don't want it here. Alright, I know this is not the right way to do it, but just bear with me. It's not a no pointer. Now let's see if I actually created the whole thing. So get my get Mesh Manager pointer, and right, you for the Mesh octree manager, octree manager, and I'm gonna say my astronaut get, what's the name of that? Get Mesh octree manager. Once I have my octree manager, I can get my pointer to that, and that's basically the whole thing that I was doing here. So I'm gonna get the root node from my octree manager, and it's going to be octree manager, and then I'm gonna get my root node. Then in the test that I'm gonna do, I'm basically gonna go all through every node, every cube that was created, and make sure that everything is fine. I kind of know already that the values that I should be getting, but before we actually do the test, let me set it back. Let me set the subdivisions back to 1, or else I'm gonna get 73 nodes, and I don't want to get that right now. I only want to get 9. All right, let me put a stop here, and hopefully that works. I don't know if that's actually a good idea of how I added the Mesh Manager inside the static file, a static model file, but I think it may work. All right. let's build this. So um, yesterday I checked how many times I've been on Twitch now doing a live stream, and I thought that I had only done about 7. It turns out I had done more than that, and I guess I had lost count. This, I know it's not a lot, but this will be my 11th time that I do a Twitch. It's kind of cool though. I actually should write a blog post sharing my first experience on Twitch and how I felt when I went live. It was something else, I can tell you that. Also, one of the things that confused me a lot when I was doing setting up for my Twitch is like all of that equipment that you need to get, like the lighting and OBS and the cameras and all that stuff. It takes some time to realize how much you really need, and you know what type of tools makes everything easier for you to go live. For example, at first I had I had bought like 2 lamp lights from Target, and they you know, they're the cheap type of lighting, right? And I think I spent like about $30 on total on that. But when during my first couple of Twitch, I realized that the lighting was so bad, and every time I was gonna go live, I had to keep moving the whole lamps so I can have the proper lighting. So before a Twitch, I would spend like half an hour making sure that the lamps would give me the proper lighting, and it wasn't didn't look that bad and everything else. So finally I decided, you know what, I'm not gonna be wasting my time, you know, on just setting up the lights. So I went ahead and I bought a Elgato key light, which has been really good investment. So okay, so that works. Let me just run this, and I think we got it. All right, so let's do a quick test so that way we know that everything looks good. We don't want to, you know, go ahead and realize that, oops, there's a problem here. So I'm gonna copy this, I'm gonna bring this over here, and we're just gonna do a quick test on all this. A new file. All right. So basically, all right. So the plane has 2 triangles. All right. And what we're gonna do, we're gonna go and make sure that the cubes that basically bound the plane are the correct ones. So the first one is the parent, right? And that has a 0, location, so we don't care about that one. The next one is this guy right here, right? This particular cube is located in location 0.5, 0.5, 0.5, and it should have 2 triangles basically that belongs to it. All right, so here we hold on, this was not nope, this was not the plane that I used previously. So I guess I lost that plane because that was not the plane that I was using. Yeah, it was not that one. Octree example is that. I guess I'm gonna have to create a new plane then. I didn't want to do that. All right, so open new. I like the plane that I had. 0, 0. All right, so what I want to do let me do a cut here, and let me move it to that side, and that will create. All right, let's see if okay, cool. All right, so this one is going to have 4 different cuts or triangles, and that's what I want. All right, so let me export this guy over. All right, now let me copy this guy and let me bring it to where I actually had my my octree test. Boom, there you go. All right, bring this to 0, and I'm gonna hide all of these guys for now. All right, and let me do this again. The other thing that I have to tell you about Twitch, if you're new to Twitch and you're planning to go live and do some live coding, is that time flies. I mean, when you realize it, you've been on Twitch like for about an hour, and you're like, what? It's already an hour? So keep that in mind. Time will fly so fast. I mean, at least for me, it flies, quick, very quick. Okay, so the first one, right? This cube is centered at the location that I mentioned, which is 0.5. And now if we look at the particular number of triangles that it contains, it actually should contain 2. Let me get rid of that. Boom. So it contains 2 triangles, this one and that one. All right, so now let's go to the next one. That one is set, leave number 1. The next one should have 4. Okay, boom, boom. And as you can see, we have 4 for that one. 4 triangles that are part of that particular cube. All right, next one. Oh, and by the way, let's check the position also. It's negative 0.5, 0.5, and 0.5. Cool. I know this already works, so I don't want to go over all of this again. Let me check my leaf number 7, and I believe that should be my last one. This one. This one is in position negative 0.5, negative 0.5, and negative 0.5. And supposedly, according to this, it should collide with 3 different triangles. So let's double check on that. 7, and there you go. It collides with that one, and that one. So we're good. Leaf number 5 should also collide with 3 triangles. That one is 5. Okay, negative 0.5, 0.5, negative 0.5. Cool. All right. So we got that down now. I think that one works. So what did we do here? What did we do? We have the static model now. Whenever I want to have an octree generated for the model, I basically enable the mesh manager, and that will basically build an octree. All right, now I wonder if the name that I gave to the function, to the method, is a good name for people to remember down the road. Because I can call it differently, right? I can call it a build octree. why don't I call it enabled mesh octree manager? See, and that's also something that I learned about building a game engine. When you have when you're building basically coming out with your own API, you need to come up and think of good names for your API so that people can actually use it in the future. Well, remember it, right? Even myself, it turns out that many times I forget the particular class or particular method that I should be calling, and it all relates to to how you name your API. So calling it enable mesh manager, I don't know if that's a good name. Probably I should call it enabled octree mesh octree manager. I can also call it build octree mesh octree. But I don't know. It's not even a good thing. All right, let's think about this. Enabled. If I'm using the engine like in 4 years, and I want to, build the octree. Well, I guess I can always change the name of the method, right? Just call the mesh manager, and we can say that the mesh manager is in charge of building the octree. All right. Actually, let me put that in the documentation then. Brief. Builds enables the mesh manager to build an octree. Details. This builds an octree for the 3D model using AAB boxes. Alright, and this one, brief, gets a pointer to the mesh manager in charge of building an octree. Alright. Let me go over here now and brief object representing the mesh octree manager. Okay, all right. Enable mesh manager. Now I'm just thinking of if that name is actually a good name to have. You know, enable mesh manager. I don't know. Let me do something else here. That one. What I want is basically, I'm gonna get rid of all of these cubes right now because I want to get I want to see if I get any issues with that bigger plane. It's already 11:10. Come on, build, boy, build, build. I am concerned also about the number of subdivisions that I actually do. Um, One seems to me that is decent. If I do two, which is 73, that's a lot of memory that I'm also consuming. And I don't know how good that would be, to be honest with you. All right. Now, me actually using the actual plane, I loaded this plane into the engine, and you know, basically I want to see the number of triangles here, right, that I get. And let's see. Now here it shows that I divided this, into just one subdivision, which just created 9 smaller cubes around it. And here actually I show that my leaf 0 has 478 triangles, leaf 1 has 578, the second one 363, 363, on and on. Now I can actually, why don't we do that? Like, let's go and change the subdivisions to 2, and let's see how many triangles do I get per leaf node. All right, and let's see how that works. Unfortunately, I couldn't go play soccer yesterday. My foot hurts. The ball of my foot, I don't know why, but it hurts when I step on it. Um, just walking kind of hurts. So I was hoping that it was gonna get better by yesterday, basically. But after I finished the Twitch, right, I knew that I couldn't go play, because even sitting here and I would touch my foot, it was kind of very was hurting quite a lot. So basically, I haven't played soccer for a whole week, because on Tuesday I also couldn't play to my fullest. I was not able to run at all, which we should have won that game, but they scored because of me. It was my fault, actually. I should have stopped the attacker, but I just couldn't keep up. My foot was just hurting way too much that day. Alright, so I have it. The subdivision is 2, and we have that. And building. So let's see how many triangles do we get per. Oh, look, it works. Man, but that took a long time, huh? That whole processing, I could tell. I'm like, I thought it went into an infinite loop actually. All right. Okay. All right. So I can see that. Okay, some leaves they actually have zero. Why? Because they may be, don't forget that they can also be, they can be. Where are you at? So I can actually show this. Octree, yes. So some of the smaller leaf nodes can actually be on top, like over here. So I'm gonna get no triangles whatsoever for that particular leaf. So I'm not surprised that I get some zero here for some of them. Now for the other leaves, if you see this, I'm getting like leaf 72. I'm getting 71, 71 triangles. Leaf 3, I get 141, 4, 0, 6, 161. Oh man, so I may have to do even more division, but if I go even deeper, that's going to create more. It's going to create a lot more, take up more memory. Leaf 8 have 0, 9, 0. Leaf 10 has 171, which in my opinion that's still a lot to do a search on 160. Yes, it's only compared to what I had, which was 1,000. Now I only have 167, 100. Well, actually, tending that I should go into do a subdivision 3. That would give me 585 nodes. But then that would also force me to do more tests on the particular cubes, between the array and the cubes. All right, all right, all right, all right. Let's go for 3, and let's see how many triangles I get per node. All right. Man, but tell you what, this is gonna take a long time. Actually, I can tell. I can sense it. And this is the moment when when these things happens. This is when I realize that you should focus your engine to do just like either to do like low poly games, like small games, mini games, which doesn't take too much memory, and just design it for that, or go all out and do like a general game engine. Um, to be honest with you, I'm more inclined to do like the small type of mini games engine. Um, all right, so I get 511 leaves. I thought I was supposed to get more than that. 585. I wonder why did I only get unless I because that's total, right? Here I'm just counting my leaves, not my parents. All right. All right. So, haha. Let's see. Now check this out. Per leaves, I get 38, 38, 4, 6, 0, 0, 49, 8, 42 triangles in that particular cube. Interesting. I get a bunch of zeros. I get 38 in this one, 39. Also 39 here. Alright, so which reminds me, what if we allow the user to set a number of subdivisions that it wants, right? 62, 60, 50 right here. That case, the game developer can actually determine how many subdivisions he actually wants. Alright, 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 alright. That would not be a bad idea if we allow that to actually happen. So here under static model, when you say enable mesh manager, you actually also allow the developer to basically determine how many subdivisions he or she wants per the character. If the character is very dense, you may want to have more subdivisions. If the character is very low poly, you may just have very few subdivisions. That, my friend, is something not a bad idea. Not a bad idea at all. Donut, 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 donut. Enable mesh manager, and we can say we can have two. One which is a default enable mesh manager, and the other one could be like enable mesh manager with subdivisions, and you set the subdivisions that you want. Or like here, say like, oh, I want 2 subdivisions, I want 1, I want 3. This is also what you need to keep in mind when you're developing a game engine. You know, you need to think how the user is going to use your game engine, right? You want to make it as simple for them to use your engine, and you need to put yourself in their shoes and think how would they actually, what would they do in this situation? What would they want to have power on? Here I can see that the developer may want to have the flexibility to set a number of subdivisions that he or she wants, right? Especially if he sees that in a particular model, right, he is quite high in the number of polygons, he may want to have more subdivisions, but so hopefully to speed up the whole engine, right? But the problem with that is that the more subdivisions you have, the more nodes you have, which means that the more tests there will have to be done to get to the particular triangle. Yes, the number of tests are going to be a magnitude smaller, but still it's a test that needs to be done. Now if your model is very dense and you don't have enough subdivisions, well, guess what's going to happen? You're going to pay the price because you're going to do a linear search when you get to the leaf and you have to do a search on the vector container. And and like I showed you here, when we had a subdivision of I think of two, um, a leaf had a vector size of about 50, I believe. When it was size of 1, the vector was of size in the 100 something, I don't recall. um, the sweet spot should be 2, because that's about 50, but still 50 to me sounds a lot, because we need to do a test between the ray and a triangle, and that seems a lot to me to do that. Kind of want to leave it at subdivision 3. And play with that. I don't know. Maybe something that I need to think about. All right. So I think this is enough for today. It's Sunday. I want to kind of relax for a while. I'm gonna be thinking about this. What should I do? And hopefully I go live soon, maybe tomorrow, with my decision, and then we go on to the next phase of what I was thinking of doing. All right, guys. Thank you for joining my Twitch today. I want to stop right here. Thank you, and I see you hopefully tomorrow. Bye, guys.